Well, I got a, a fine mess going here. So just to show you, I have my espresso machine just all the way apart because I was having some flow problems and I thought that I had an obstruction because I had found a little piece of a seal that had, I thought, come apart and was stuck in the end of my steam wand. There you can see the little piece of seal that was in there. Now, as it turns out, I don't actually think that was a seal. I think that was a broken off piece of thread sealant because it looks like they have used on some of this some sealant, and that may have actually been internal to one of the threads, broken off, because again, it looks coloring wise a lot like the thread sealant that was on some of the metal connectors. But I've went through the whole thing, traced the full water path, and I couldn't find any obstructions, which leads me to believe that it was probably the pump going bad, and so I've got a new pump that I'm about to put in. But I thought, while I've got everything apart, we take a little look at what makes an espresso machine go, right? What are the parts in here that really help this thing do what it does? And we'll start off looking at the heating element. Now, this is an Ascaso Dream, and they use this big thing here, this Thermoblock. And so with these Thermoblock systems, they're known for heating up super, super, super fast. And so part of the reason they can do that, I'm gonna zoom in on this thing, is these Thermoblocks, the way they work, they heat up kind of the water directly in a thin pipe. So this thing's actually two big kind of pieces that are screwed together. You can see the bolts in the end. So the first big piece, this big piece of brass, this is basically your group head. And then the heating element sitting here on top is like the Thermoblock assembly. And basically what they do is they've got, I believe it's stainless, and that stainless tubing is coiled, and so it goes in here and you can see it comes out the top because there's probably a few loops of that tube going around, and following it, so right next to it within this big aluminum block, is the heating element. So here you can see the two leads from the heating element, and so they can basically run that really close to those tubes, and the big aluminum block is really to help both conduct heat out of this element into the stainless tube and also to retain some heat. Ascaso is kind of known for, they don't cool off real fast, and part of that's because they also have this big molded piece of foam that actually, if I fit this thing through there, all right, so there we go. You can see it's like a rigid foam piece that insulates this thing, and they're known for, they get up to temperature, and then this helps with thermal stability. And so that's like the aluminum block both conducts, it helps hold heat in, and then this big rigid foam insulator also helps keep the heat in once this thing heats up. So in the top of this, you're going to have a thermal fuse, and then over here is going to be a temperature sensor. So it can monitor and give feedback to the controller about what temperature this thing is, and worst case scenario, if this thing gets too hot, this kind of fuse will burn out. I don't know if it'll actually reset or not, but it should basically trip. It's basically like a breaker that runs on heat. So the water path is interesting. The water goes in one side, comes out the other, and then fits around through some other stuff that we're going to look at, and actually comes in through the top of this, and the hole there at the end of the group head goes all the way through. So that was one of the places I thought may have been clogged up, because that's one of the smallest orifices in the entire system. But it's all clear, and I've checked the tubes as well here, and yeah, there's no restriction that I can find in the group head, so it doesn't seem to be anything stuck in there. So some of the other things that kind of help are understanding how it switches water flow. And so I've got the solenoid all apart here. So let me briefly get the solenoid back together. All right, so I've just loosely gotten the solenoid assembly all back together so that you can get a good look at it. So basically on the right-hand side here, you've got these two orifices. Now, one of these is going to be the inlet for the high pressure, high temperature water. The other is the outlet that goes to the steam wand. Now, what normally happens, and if I pull this thing apart so that you can understand, is whenever the solenoid kind of is in the off state, open this thing up, there's a little plunger in here that you can see. And so that little plunger has a spring, and that will keep the plunger from going in. It pushes it out. And that plunger is being held, if you can see in there, see there's a little hole. And so the plunger is sealing off that hole, and that's kind of the default state, which means the water cannot come in from the inlet. The water is only going to be able to go out the steam wand. However, your steam wand has a valve on it, and on most machines, that's how it works. So I'll show you up here. Right there's the steam wand. So if that's closed, then in this system, the water can't go anywhere because it can't go out the steam wand because the steam wand's closed. It cannot come through this manifold because the solenoid is keeping that hole closed. Now, whenever you want to do steam, it heats up the water really hot. You can manually open your steam valve and it never enters any of the solenoid or manifold assembly. In this system, it just goes from one of these holes out the other. And so whenever you go to pull a shot, this solenoid will fire and it's going to pull that plunger back in. Now what that does is it opens this hole in the manifold. So whenever this thing opens, it allows your inlet to flow through the manifold and go out through your group head, and so you can pull a shot. But now here's where the little clever part of the way these solenoids work is. There is an extra outlet at the back of the solenoid. That's what this is. And this goes to the drain on the machine. Now, what's interesting is when the solenoid pulls the plunger in, there's another seal on the back of the plunger. There's these little soft rubber seals on the front and back. And inside, let me see if I can show you, get the light, you can see there's actually a hole right through the middle of that thing. So it's very important whenever this solenoid fires, it pulls the plunger up against that seal, and so water can't come out the back side of this, because if it could, the water would go around the plunger and come out the drain. So it pulls this thing all the way closed so water can only go out your group head. And here's where the kind of magic happens. How do they keep water from standing on the puck after you pull a shot? Well, remember, this is all high temperature and pressure because you've been pulling a shot. So it's probably at the end of your shot running, 5-6 bars. And whenever this thing shuts off, it closes back up, and the water, you can see there's these channels cut in this thing. And so when this thing goes back the other way, it closes up so that no more pressure can come in, and also water can't flow back from the group head back into your system. It can, though, flow out the drain. And so, since this is going to be much lower pressure than what's inside the manifold and pushing on your puck, the water will seek the lowest resistance, which means the water, instead of standing on the puck and trying to push on the puck, well, it's a much easier path to get drained back out the tube. There's also some other hydraulic principles in there that will help draw that water off, like siphoning and stuff like that. But that's why whenever you get done pulling a shot on a system like this, you won't end up with a ton of water draining out. You won't get a lot of afterflow after your shot or anything else like that. This is in contrast to the Breville Bambino system, which does not work like this. Because the Bambino does not have a manual valve on the steam, they can't do this stuff. And that's why those Bambinos end up with a lot of water after the shot, because they can't drain it back off like this, because they use the solenoid in that system to switch between shot and steam. And since they're using this to switch between that, that means without that manual valve, they end up leaving water on top of the puck. So what else can we show you in this system? Well, what about how do they control your overpressure? So let's take a look at the OPV valve. These are also really interesting little systems. So the OPV has input, output, and also a bypass, so that if the pressure is too high, it actually will have somewhere to go, because obviously you only want so much pressure on the output side. So if there's too much pressure on the input side, where does the difference end up? Well, it's got to go out a drain, right? So in here is there's a couple interesting things. Number one, there's a one-way valve up top, and then there's a pressure compensation valve in the bottom, and that's what you can adjust on adjustable OPVs. So let me back this thing out, and we'll take a look at the OPV. Now I got to be careful because there's a spring in here and some seals. So I've got it marked so that I can get it back roughly adjusted. So it's got a lot of resistance, and that's not because there's anything binding up. It's just that seal is rubbing on the inside and gives it some friction. All right, so there's the bottom, and that's just, again, basically a fancy screw with a little through passage. And then here's the interesting part, all that's in here. Okay, so what's in here? Two things. There's a little spring and a little, I think it's a glass ball. I can't say for sure whether it's glass, but there's basically just a little ball. And so what happens whenever you adjust your OPV is you're just adjusting the strength of the spring pressure against that ball. And so whenever the pressure inside is higher than the pressure you've got adjusted, it just pulls and the flow goes around this ball. And then it comes down through this screw and out the sides and out your vent. And that's at the bottom. That's basically how an OPV works. There is, I believe, inside of that, I don't know if you can see there's basically a seal down in the bottom of that thing. There we go. Right, and so that ball pushes into that seal, and when there's too much pressure, it just opens up. All right, so up top, I mentioned there's a one-way valve, but a one-way valve is essentially the same thing. It's just not adjustable. And so here, no, I had it correct, by the way. The flow is, here's the input high pressure, and here's the outlet. And so what there is in there, as you can see, there's a seal, and within here, there is another spring pushing this way on another glass ball. And I can try to get this thing apart for you. All right, so there's the inner seal, and there's the ball, and then there's spring. And so it's kind of the same thing, same concept. Whoop, don't want to lose that. Let me put it back together. That way I don't flip that spring or lose that ball or anything like that. All right, so how does that work then? Well, it's a one-way valve. That way the higher pressure should be on this side, and it should be able to push that ball open and then water go this way. But if something happens, it can't backfeed, and that's all the one-way check valve does. So it's just making sure that the flow goes this way. And again, if you get too much pressure, it will shunt out this way. And so on most systems, this will go back to your water intake. This won't go into your drip tray because this is still clean water. And so, you know, they'll recycle that back into your tank for the overpressure relief. All right, well, now it is time to turn our attention to the pump. This is a vibratory pump. And again, this is out of my Ascaso. I have gotten the pump changed out on my other machine, just doing a little bit of testing over the next couple days, making sure I don't have any leaks. But this is vibratory pump, and it's kind of interesting the way these things work. There's some pretty good diagrams online, and I've found at least one really good short video that I'll link that kind of shows how these work. So this is the water inlet, and this is the output. And so the water enters here, and there's an internal little piston that has a one-way ball valve on the side. So it's similar to that one-way check valve I looked at earlier, where there's a ball being pressed in that opening. And so whenever this thing actuates, it pulls the piston back, and water can flow through the inside and out that valve and fill the internal chamber. Now there's also a one-way valve on the output. So it's got a ball on this end so that water can flow out this way, but it can't return in. And so what happens is whenever that piston pulls back, water cannot come in this side, but it can fill through the inside and come into this internal chamber, right? Now, whenever this thing then relaxes, it'll push the piston back out, which means water can flow out. But because there's that ball pressed in the end of the internal piston, whenever the piston pushes out, water cannot force its way back out this way. And so that's basically the way this thing works, is it vibrates because that piston's going back and forth. And let's open it up and we'll look inside and I'll show you those parts. It's taking a little bit of prying. This thing is not coming easy or quick, but there we go. We finally got her popped open. All right, still got a little water in it. All right, so the outside assembly here, all right, this is basically just a big solenoid coil, so it can be energized and then this will be magnetized. And like I said, in here, there'll be a piston. So next thing, how do we get this open? Do these just unscrew, or are they permanently? All right, so just an update for anybody who ever gets one of these ARS vibe pumps. I'm just going to go ahead and say they are not user serviceable. So I've been trying to get this thing open without just destroying it and have just failed. The portion here does have wrench flats, and I've turned it, but it doesn't unthread. It's just somehow turning. I've also, you can see I gouged this a little bit. I had this thing in a vise thinking, well, maybe these have been spun together or something. Again, also turns without unthreading, which means I'm just gonna have to cut it right there to get this thing open. So I know that sometimes people cringe, you know, why did you just destroy something instead of trying to be careful? Well, try to be careful, and this little pump's time has come to an end. So again, I'm gonna go cut this thing open so we can take a look inside, because, well, that's all we can do. So be right back. All right, well, a little work with a hacksaw. And there we go. All right, shouldn't surprise me, but the high pressure side was quite a bit more robust. There we go. You can see just how thick the plastic is on the high pressure side. It's really thick. And even where I cut, I thought it would open up and allow this stuff to come out, and it still doesn't, because I guess I didn't cut it in the right spot. So it turns out it's going to be very difficult to show you all little details, because the way they made this thing makes it very difficult to get it all the way apart. So even what you're seeing, this thing has still got multiple parts that are internal that I don't know how to get apart without going absolutely nuts on this thing. But essentially, here's your water inlet, and there's a hole in the middle of this piston. So again, you got your solenoid, and so this thing can pull this piston back. And when it does, what's very interesting is the one-way valve. Again, water can come in, but there's a seal inside of this chamber that you can see down in there right there that seals around the tip of this piston pretty tightly. So you can see how tight that fit is. And again, there's a rubber seal in there that makes it even better. So when this thing is pulling back, water really can't go through this and around the outside of the piston, because you can see it just fits so tight in there, and there's that internal rubber seal. So the front chamber basically is this little plug inside of that, right? So there's basically, that's where the water goes. And how does the water get in there? Well, the tip of this thing has a little rubber seal in it. And the way it works, when I got to looking at it, man, this is hilarious. There is a tiny little spring in here. And the way it works is the spring is actually pulling this piston closed. So I'll see if I can hook onto it, this little bitty screwdriver. All right, there's a little bitty spring in there. And the spring is kind of a cone shaped so that it can't get pulled into this little internal hole. That's it. The way it's being retained is it's just big on one end. So there you go. You can see there's the seal, and the way it's shaped, it's got like a little hole on one side so that it's being pulled and closing this thing. So again, the way the pump works, it's all, you know, sealed up. And so you've got these springs working on this piston. So whenever this piston gets pulled back, it can push water out the end into this little chamber. Now in this little chamber, again, stuff I can't really show you very well. If I turn it like this, you might be able to see inside, if I get it really close, that there is a little ball valve in there, and I don't know that you can see that at all. But inside of here is a little ball with a spring, and so water can go this way, but since the spring pushes the ball this way, any pressure on this side shuts it, and the water cannot come back. And this is the high pressure side. So in this pump, again, water can come in, it can come through the middle of the piston and push out the end into this chamber. and it can push water this way. So when the piston opens, it can basically fill that little chamber, and then whenever the solenoid wants, it can push it the other way, or the springs themselves will push it back. And since water can't come this way because this end is sealed, it will just pressurize water out the end. And so that's the vibratory pump system. You got a really big chunky AC mains driven solenoid here, and it's just essentially going to pull this thing back and then let it go, and the springs push it forward, and that's the way it pumps. Again, I wish I could get everything out of here, because you can see there's internal seals here, there's a little seal and spring in here, and then there's a ball and spring and a seal in here. So you got one-way valve, and that basically works with the solenoid and piston to pressurize your stuff. All right, I was a little dissatisfied with myself. I thought, am I really going to quit like that? And the answer is, of course not. So let's get the rest of the parts. So I've hacked open the front here. Okay, so that's the one-way valve on the high pressure side. You can see it's just a spring and a little rubber seal that pushes in there, and so that will allow water to go that way, but not this way. And I have tried like the dickens to get the internal seals out of here. I've used picks and stuff without basically, I think, a grinding wheel or something. I'm not going to be able to get this thing out, because it looks like those seals, they are not just retained by friction or anything like that. They are like in between this thing whenever it got assembled, and so I can't pull them out for anything. And I don't have a cutoff wheel or something to slice that thing open. But there are actually two seals inside of here. There's a small, what looks like, it looks like an O-ring, but again, I haven't been able to pick it out for anything. Looks like a little Teflon O-ring, and on the back, there's like a big Buna end seal. And I think one of them, basically the small O-ring thing is gonna seal on this stem, whereas the big Buna end seal probably is a face seal somehow for this thing. Now, last thing to take care of, let's get the little internal piston seal out. If I just pull, will that thing just pull out if I pull hard enough? No, but I can cut it. I can cut it. Where's this? All right, so I've destroyed it. And you know, this is part of it. When I said I was disappointed in myself, I'm like, I'm treating this thing as if it's delicate, and I've already destroyed it, right? Why am I being careful? So there's the internal piston seal right there. And again, you can see it's got this spring that basically pulls on it. So let me see if I do this. Right? A little end seal, and that's what plugs the end of this little piston. Right, that little stem there. It's kind of chamfered to make it seal up good. And then the back of the spring, which I have mangled, you can see how it's got the bigger loops on the back, and that's how it was being retained in there. So there's the inside of a pump, of a vibratory pump. Now, again, do they all look like this? The diagrams I saw before I cracked this thing open were that they use ball valves. This thing doesn't use any ball valves. It used these molded rubber seal plugs, but they serve the same purpose. It's functionally the same as the diagrams that you'll see. But anyway, that's it for the pump. If you saw anything that I did totally dumb, if you're like, yeah, you could have got this thing open easy if you'd have done XYZ, feel free to let me know. This one's done, it is what it is. But that's it for me. If you got any questions, as always, feel free to leave them down below. Thanks.